We're going through a small worksheet and solving questions about the heat equation, given this nice little reference table that I came up with. Let's go on to problem number 2. All right, so problem number 2 says that a 350-gram sample of water at 25.0 degrees Celsius absorbs 9,358 joules of heat. What will be the final temperature? So once again, we're not talking about ice, we're not talking about steam. So the equation we're going to set up here is Q is equal to mc delta T. And once again, we're going to take the numbers that we know in the problem and we're going to place them into the equation. So this time, in the previous problem, it was heat we didn't know. This time we know heat. It's going to be something else we don't know. All right, so we can do heat first. So Q is equal to 9,358. We know the mass of the water is 350. And C is the specific heat capacity of liquid water, which we know is 4.18 joules per gram Kelvin. And delta T is what we don't know. We don't know in this problem how much the temperature of the water is changing. Okay, so this is what we want to solve for. How can we get this into an equation with delta T alone on one side of the equation? Well, the first thing that might be nice is simplifying this. So 350 times 4.18 is equal to 1,463 times delta T. And now, to get delta T alone by itself, we just need to divide both sides of the equation by 1,463. This is just simple one-stage equations from algebra. All right, and so 9,358 divided by 1,463 is equal to all of this. All right, so this is going to be something that is measured in Kelvin or degrees Celsius. And so how much precision out of this number do we actually want? Well, here's the temperature we already have. So this gives us the temperature down to 10th of a degree Celsius. So let's do the same thing here. So I will just write this as 6.4 degrees Celsius. Okay, so I answered the question and I'm good to go on to the next one? No. Let's take a look at the question. The question is, what will be the final temperature? I didn't calculate the final temperature. I only calculated the change in temperature. So this is a little bit of a trick. I know that the temperature of the water changed by 6.4 degrees Celsius. Did it go up by 6.4 or down by 6.4? Read the question, pause the video if you need to, and see if you can find the key word that's going to help us answer that question. The key word here is that the water absorbs the heat. So the water is taking in the heat, so it's going to get warmer. So the final temperature is 25.0 plus 6.4 for a total of 31.4 degrees Celsius. And that is our final answer, the final temperature of the water. Okay, so just a little bit of just applying the equation and using our minds a little bit to get to the answer we need to get to.